Start recording this so that we can have that. So, right, hopefully you found the practice exam and the instructions. I'll be going over this basically from memory. I haven't really taken a look at it since just adjusting it. So let's go. But I've been using these questions for a while as practice problems. All right. So, all right. Again. So first off, I nulled out these questions as kind of extra practice. They won't be on the exam, but they're very good questions to know. So the string value Hal's moving castle is a valid string, right? Double quote, Hal's moving castle. Why isn't it a problem that the single quote character in the word Hal's isn't escaped? Right? Because in most programming languages, doing something like that's actually kind of an issue. Where if you do, where basically if you have a string, right, both beginning quote and end quote mean begin of string, but here in Python, if you open with double quotes, then you close with double quotes. Similarly, if you open with single quotes, then you close with single quotes, and double quotes are treated as text. So whatever you opened with, its opposite is treated as just text. So if you open with a single quote, double quotes are text. If you open with a double quote, single quotes are text. Very nice feature of Python. You don't need to escape. It's not wrong to escape the quote by using a slash, but there you go. What's the main difference between a dictionary and a list? Order. Order. Lists have orders. Dictionaries, at the end of the day, don't really have any order whatsoever except for whatever got inserted first. And even when I initially wrote this question for Python, that wasn't true. Python changed over the years to make sure that you could list things would be listed in order. The other key difference is that I would take. So that's one thing I would take. Another answer I would take is lists use numerical indexes that are in order and contiguous, and dictionaries use arbitrary keys. They can be anything. Again, that's a bit more detailed than what I would need depending on but it also depends on the point value and instructions. If L is a list, what does the expression L::(-1) do? We've seen this one a number of times, hopefully by now, which means it means we take a list and we create a reversed copy of it. Right? Remember that that's doing a slice produces a new copy. So this would simply produce a reversed copy. If we had just : and not the -1, it would produce a full copy of the list using slice notation. And how can we use slice notation to get the three last characters of a string? Right? The three last characters of a string are always open colon, right? Oh, sorry, not open colon, but open brackets, colon to start doing the slice notation. And then we don't care about the beginning of this, or rather we should say, we don't care about the end of this, we care about the beginning, so we do -3 up to the end. That is how you do the last three characters. Right? You use negative indexes. You could also do something like length of the string -3, but here it's just easier in Python to do that. So those are some of the practice problems. Oh, let's see. I have a coin that is slightly weighted in favor of heads. It will land on a heads 55% of the time. How would you simulate this using the random module? Well, in this case, you can't use head and tail directly. You can't just use random.choice. Instead, what we would need to do is do import random, def weight flip. And here, I would just simply, there's a lot of ways to do this. I could do random, random.random. And that gives me something between 0 and 1. So there's a few ways to do this. You could use integers. Here I'm just going to use random, not random. If a randomly generated number between 0 and 1 is greater than, so I want it to be 55% of the time it's heads. So less than, and since 0 is inclusive, less than 0.55, return heads, else return tail. Otherwise, we can also simplify that to a single statement, but notice that you could also use randint. You can also use randint to do this. Okay, but here when you want to give something like weight between two objects, if you don't want to be an equal chance, you just kind of do it like this. Okay, let's go on to actual questions now. So again, this one was on a prior exam. Suppose we had an example file called temperature.csv. Okay, we don't have an example file here, but we know what. But I tell you what it's going to look like, and it contains the daily highs and lows for temperatures recorded in Philadelphia. The temperature is composed of 3 fields per line, which is the date, the high temperature, and the low temperature. Each field is separated by commas, so the contents of an example file might look like this. More realistically, it would look something like this, where it would be date 1. Oh, here, I'll just copy this. More realistically, it would look something like this without the spaces, because the file doesn't need your spaces. It just needs the commas to know what the difference is between the two. And also, it would look something like this, where the fields are separated by commas. Okay? And ... just simply mean that, hey, there's going to be an arbitrary number of these, right? So write a program that calculates or prints the following: the hottest high temperature, the coldest low temperature, the average temperature of the entire file. Now, what I don't want you to do in these kind of questions is just simply find the highest, by I, find the highest value and print that out. That shows me that you know how to find the biggest number by I, which is not really helpful here. The entire point of an example is so that I can give you an input and output example. If you're trying to get the answer from the example, you're not really. The examples are there to help you check your work. In other words, when I provide examples. Okay, so let's go ahead and see. We have program that calculates or prints the following: the highest high, the lowest low, and the average high temperature. We'll work on the first two simultaneously, and then we'll work on the last one, which is def read temps. And here what I'll do is I'll just put in the file name over here. I'll take it in as an argument. You can do it. You can construct the file reading in a bunch of ways that you want. I like doing things as functions, and I love it when I put in the file name as a argument. That is just my personal preference. You don't have to do it that way if you found a different way that works for you. Okay, so there's the file name, and then I'll say like the data is equal to let's see, data is equal to open, file name, and then in the read format. That's all we'll need for this. Okay? So here we go. For line in data. So when we're reading files, generally there's two ways to do it that are super useful. The first is to do it like this as a for loop. The other way is to load it up like this. Data.readLines. Either of those work. Use one or the other, but either of those work. I just like this way works for here. So for line in data, we need to iterate through it, and we got to find the biggest hot temperature and the smallest low temperature. So highest. So the day with the highest hot temperature equals highest temp. We're going to need to add some more stuff also later on, but for right now, I'm just putting down the obvious things. There's other obvious things, but They may not be obvious at first glance. So for line and data, for each line, what we need to do is now is that the data looks like this. It's separated by commas. We've got date, high, low. So I'll call this fields, or you could call it parts or whatnot, is equal to, we're going to take that line and we're going to split it up. We're going to split it by comma. That tells the Python, hey, let's turn this string into a list, and we know what's part of a list by saying, hey, it's separated by commas. So this is the first item because it's before a comma, the second item in the list, and the third item in the list, because that's where they occur for commas. Is everybody able to see that just fine, or do you need me to up this size of the screen? Okay. For line and data, fields is equal to line.split. The first field, index 0 is irrelevant. It's just the date for right now, but we'll save it. We'll need it to print out an answer. Fields 0. The high is equal to, and let's convert that into an integer so we can actually do some useful comparisons on it. Fields 1. Low is equal to int fields 2. When working with a file, remember that everything is a string, and that if you want to use numbers that you're extracting from it, you're going to need to convert it into a number. Okay? There we go. And so now that we have this, we can actually ask questions. So if my current high temperature, because we're looking for the highest high and the lowest low, if high is greater than highest temperature, then that temperature is going to be, then that new temperature is going to be the current high temperature. And conversely, if we're looking for the lowest low, if our low value is smaller than the lowest temperature we have seen so far, then lowest temp, then that becomes the new lowest temp. Lowest temp equals low. Now, that's all well and good, except it said the question was not find the highest. I've been misstating the question. We found the highest high, we found the lowest low, but what I'm asking for is the day. Now, if you were to find the highest high and the lowest low, and if you turned this into your answer, for each of those parts, you'd probably get 4 out of 5, right? In my book, this is a 1-point mistake, okay? Again, this is when I started doing rubrics, not really, the rubrics are better indicated by what you'll see later, but this is a very good, there's no, you got 0 points because you missed it completely. No, no, this is not completely missing it. You've got the logic here. You've just, in your haste, made a very human error, okay, which I'll mark, but not harshly, okay. So here to get the answer, we just need highest day is equal to lowest day. So now we create 2 strings that will correspond those answers, and now we just simply say highest day is equal to the date, okay, and the lowest temp is equal to date. Now there is one thing that I want now the extra credit, if I were to give extra credit for an answer, it would be recognizing that starting at 0 for your temperatures might actually need to be a bit different. If we're measuring temperatures in the Arctic, for instance, then the lowest temperature could very well, the highest temperature could be very well be 0, a negative number. The highest temperature could very well be a negative number, depending on what scale we're using, and that could be mildly problematic because it might not actually, record that. So what I'm saying is, if you wanted an extra credit answer might look something like this. Set your highest temperature to a ridiculously low number, and your highest temperature to a ridiculously high number. Why? Well, I can guarantee you that the actual temperature is going to be lowest than this, and I can guarantee that the highest temperature is going to be something higher than this. But I can't guarantee that for 0. 0 might be might actually be the hottest it gets. 0 might actually be hotter than it actually gets, and therefore if you put in 0, it might not actually record your hottest temperature if your hottest temperature is like -2. Make sense? Okay, but again, that's something that is above and beyond what I'd be worrying about on an exam. Just worth mentioning. Okay, oh yes, and the average high temperature for the entire file. So, okay, we can also add on to that as well. And then we should probably give those answers back to the user. So, so here, to find the highest temperature, the average high temperature, I'll do total high and num dates. Okay, there are probably ways to do this a bit easier, but what we'll do is that just to simply add on to what we already have. So here we find the highest, we find the lowest, and then over here I'll do the third part, right? I'll do the third part third, which is the total. To find the average temperature, the average hot temperature, we just add together all the highs. Equal to high plus equals high, and num dates plus equals 1, right? So there we go. And then what we'll need to do is that we'll return, highest day, comma, lowest day, comma, and then total high divided by num dates to get our average. So those are 3 answers. Now you can see how basically I could start with just one. I did the first 2 at the same time, and then I just added it in. Okay, moving on because I want to make sure I have plenty of time. The bulk, let's see. Okay, yeah, I'll skip this one for right now. I'll come back to it. The bulk of the exam will be a lot of questions like these. String manipulation functions, list manipulation functions. About 40 points total are going to be on Monte Carlo and file reading. The rest are going to be stuff like this. Okay? Okay, so here again, and again, the points indicate kind of the difficulty of the question or how many moving parts there are. This one's a fairly straightforward one. Un or un. If a string begins with un, return a string without the un in front. Otherwise, return the string with un added to the front of it. And we can assume that the character is 3. This is more important for Java, but you can assume the string is at least 3 characters long. That way there will always be un or there won't be an un, There's no having to check about out-of-bounds exceptions, in other words. So, and then here are example function calls attached to these, right? So these are your guides. They will be attached to every problem that is a function, which is here's the input, here's the output, here's the function stub, here's your input, and if I give you this input, I expect this output. So if I give you untied, I don't know why it's copied those string notifications wrong. If I give you untied, I expect it to become tied. Unable becomes able. Necessary does not begin with un, so we add un in front, right? So this actually is a fairly short program because all we are doing is an if-else statement. We're asking if it begins with un, do one thing. If it doesn't begin with un, do another thing. Make sense? So let's go ahead and just check. How do I check if something begins with un? We don't want to use the word in here because in would imply the entire thing. That is a common mistake, but not too far off the bat. Okay? So if word, the first 2 characters, I would do a slice of this. Or if you're feeling really uncomfortable with slice notation, you can take advantage of the fact that I said that it's guaranteed to be at least 3 characters long to just simply concatenate the first 2 characters. Right? So there's one way to do that. So that's one way to do that. I personally prefer the slice notation, and so should you. If from the beginning up to but not including the end. is, sorry, up to but not including index 2 is un, so the first two characters, right? You can always figure out the length of the slice by taking the end and subtracting the beginning. It's 2 characters long. If the word begins with un, then we want the character without the first two. Then we want the character without those first 2 letters. So if the word begins with un, remove the first 2 letters, which would be word. And in that case, well, we have the first 2 letters. It went up to but did not include index 2. So the rest of the word is start at index 2 and go to the end. Make sense? Again, slicing is your friend here. Slicing makes this problem easy. Okay. If you don't have slicing, if you don't use slicing, that means that there are ways to do this. It's just annoying because the easiest way I can think of to do it without slicing is using a for loop and concatenating a string starting at index 2, right? It's kind of annoying, but it would work. Okay. Now, otherwise, if it doesn't start with un, we add un in front of the word, which is even easier because that requires no slicing whatsoever. It just requires us to glue glue it together. Un plus word, right? If it has un, remove it. If it doesn't have un, get rid of it. And then when you've got this, you should be able to, test it very briefly, very quickly by copying in the example I have, running it, and say we put in untied and we got tied, right? Your input and output matches. That isn't a guarantee. Your input and output matching isn't a guarantee that it's right, because again, if you hard code the information, it's definitely not right. But it's probably a huge indicator that it is. If it works, if you're just coding along and your input-output pairs work, you probably got it right, move on, The worst you could have made at that point was like a minor error. Okay. Min-max difference. Saw this one being talked about on Discord. It gets scary because there's a lot of numbers in the examples, but honestly, again, this one ain't too bad. Given a list of integers, return the difference between the maximum element and the minimum element. You can assume the list will have 2 or more elements in it. Again, those you can assumes were written for Java. This one again, not so bad. So first off, again, we could use the same kind of loop over here. Biggest is equal to some very small number, right? Because if my biggest is equal to 0, I won't be able to find the negative 100. Then I could say the smallest is equal to, smallest is equal to some large number. It doesn't really matter. And then I could simply do for num in range, not in range, just in the numbers. For each num in the numbers, check if the current number is bigger than the biggest, check if the current number is smaller than the smallest. I'm not going to finish this one because honestly, this is the slow way to do it. The easy way to do this is just simply say, hey, what's the difference between the 2 biggest numbers? Return max numbers minus min of numbers. So part of the reason I also include this one, not just to give you practice, but also to point out something. If it's valid in Python, you can use it. Unless, and only unless, I say in a problem prompt, you cannot use X. Make sense? If I say, if it exists in Python, you can do it. I don't care. You should be able to use the skills you've learned. Okay? Because if I want to test you how to iterate through something to find the biggest and literally make you do that, I can write a problem that makes it specific that you have to do that. Like this one. You can't really just min and max that without using some tricks otherwise. And at that point, you're just making your work harder, maybe? Or doing some stuff that you would have to already know and mastered that stuff. So here, again, don't be afraid to use what you know, what's built in. Min and max are beautiful functions built into Python. So here, again, I will go back over the extra practice as we have time for it. Okay? I just want to make sure I hit a bunch of everything. I think we're going to have plenty of time, but I do want to make sure we have I do want to make sure. First half. Oh, I love this one because again, now this is the one where I would definitely test strings. Okay, given a list of things, return the first half of the list. This one's kind of nasty, to be honest, because you got to think. Wait, what's half, and where do I cut it off? So here, let's take a look at our examples. Here we have 1, 2, 3, 4, 5, 6. And so the function should just simply give, so here I didn't bother surrounding it with these. I didn't bother surrounding it with the function call. I just simply showed the input-output pairs. 1, 2, 3, 4, 5, 6 gives us 1, 2, 3. That makes sense. Here, 15, 31, 21, 17, 28 gives us 15 and 31. So this one teaches you something very important that I didn't necessarily elaborate on, which is how should ties be performed, which is that the first half should be, if a tie, and I'm kind of saying, if a tie is going to happen, if there's like an odd number, right, which side should 21 go on? Here, actually, believe it or not, the reason I'm doing this is because I'm lazy and because it's this is the easier solution to make it smaller. You'll see. And then here, A, B, C, D, E, F, G, H, right? We've got another 8 letters. It doesn't, and the point being, it's that this should work on anything. It doesn't matter if it's strings or not, or it doesn't matter if it's integers or not, right? It's a slice. We know it's a slice, therefore we know this is kind of a one-liner. Not most of what I write isn't going to be one-liners. These questions just happen to be one-liners that are tricky. I like these ones. So first half should return the list. And then we want to return the first half of the list. So first off, recognizing that if this is a 5-point problem, recognizing that this is a slice already gets you a point or two. Leaving this side blank, leaving the left side blank or starting at 0, that's also another point, you know? So the ending point is the more important part, but in recognizing the first steps, that's worth something. Okay? So don't leave your questions blank is what I'm saying. Can't give you credit for blank questions. Okay? So now what we need to do is figure out how to do this. Now, we know how big the list is, though. Or rather, we can figure out how big the list is. Okay? And I'll actually go ahead and stop making it a big one. So the size of the list is len, okay, of the list. That's how big the list is. Okay? So let's go ahead and kind of just think about this. The length of the list is 6. The length of this list is 5. Okay. Now, if I divide this by 2, because when I think halving, I think divide by 2, which is kind of a good place to start. If I do 6 divided by 2, right? If I do 6 divided by 2, that's going to give me 3. That's the size of what I want half the list to be. And if I think about the slice, what would happen if I plugged in, if I don't plug in 3, obviously, because then that would give us the first 3 characters of everything. But for this example, if we use 3, this would go up to, but wouldn't include index 3. It would give us the right answer. Similarly, if we 5 divided by 2 is what? Or rather, well, that 5 divided by 2 is 2.5, right? So what I want is maybe 5, and there are no 0.5s here. So maybe what I want for the middle, let's just go ahead and go by this hypothesis. Middle index is equal to size divide 2. That way we can, the divide makes sure it's an integer. So 2.5 becomes 2. So goes up, so here we have 5. It goes up to, but it does not include index 2, right? Index 2 being the middle point. And over here, 8 divided by 4. 4, this goes up to, the first half of the list would go up to, but not include index 4. So the middle index, so going up to, but not including that middle index would work. And that's why I kind of made it this split this way. because you don't need to do any additional annoying addition or subtraction. Okay. There we go. Write a method. Okay. This our first 10-pointer here. Much more kind of on the scale of what I would want to see on the exam. So, write a method called hasWildcat. Given an input string, word, return true if the word contains cat, but the middle character can be the middle A can be any character. So it becomes much clearer. It's phrased weirdly. Sorry about that. But I feel with the examples, it becomes very clear. And you can also see the artifact showing that this was written in for Java because the true and falses are undercase, as opposed to capitalized at the beginning, like it is in Python. So here we go. hasWildcat. Kitty is false. It doesn't have C something T. Tomcat returns true because CAT is in it, right? Now, catnip with a 4, kind of catnip kind of leet speakified, right? So C4T and 1P. That also will return true because, again, we're looking for a C followed by a T, C followed by a T. Sorry, C something T. Okay? So, what we should do is we should iterate over this string, okay, until we find a C. So, that's our first kind of point. We can't spell cat without a C, right? Make sense? So we're going to look for a C first. So for letter in word, if letter equals C, and then we could keep, I'm just going to fill this in later, in a bit. Remember to make this a string. So if letter is equal to C, we'll figure out that in a second. So if I go through this word and I don't find a single C in it, right, then I should return false, right? If I don't see a single C in it, or if I don't find something that finds my pattern, it's not a cat word, right? So if I go iterate through this entire string, I'll return false. Okay, so here we go. So I'd probably break it down like this in the rubric, iterating through the string, iterating and finding the C, iterating, finding the T, returning true or false correctly. And the final one, as we'll see, which would be worth 2 or 3 points, would be making sure ensuring there are no errors. I've already, and let's see. So if the letter is equal to C, if the letter is equal to C, then I have to check if not the next letter, but the letter at the index 2 over is that. And right now I'm just iterating through this string, right? I'm just iterating through this. I can't check any of the indexes. So I need to use the range function, right? Or I can use one of my other favorite things, which is enumerate, but right over here, but I'll use the range over here. Range, yeah, it's better to use enumerate here. In range of length. So here instead, in order to get access to being able to check two letters behind me, 2 letters to the right of where I am, I have to go over by index. So for index in range length of word, right? Make sense? We have to check index by index. Let's go ahead and get, and now what we can do is we can keep the rest of the code the same by saying letter is equal to word at that index gives me the letter. If letter equals C, okay, in that case I'd want to check if the letter 2 to the right of me was a T, which we could do as a separate if statement, but I'll just simply say and over here. And word index plus 2. Okay. And word index plus 2 equals t. So if we found our letter and the letter 2 to the right, index plus 2, that's what that means. Index plus 2, 2 to the right is equal to t, then we found our thing, return true. If we didn't, then we just simply continue on with the next iteration of the loop. No worries. So let's go ahead and try it on catnip. Right? Has wildcat. And what we'll do is we will say C4T M1 capital P, and we will print that out. And that should work. That should work 100%. True. Okay, tied. Yeah, because I'm still printing out that one over there. Now you might be thinking, great, I'm good to go, I'm done. But you're missing something here for this one. There's a reason this one's worth 10 points. Let's go ahead and try kitty now. False. Let's see. For range in length word. Okay. Okay, that's fine. It's going to be fine. Oh, that was the word that I want to test. Taco. Error, string out of range. So this crashes with an error. Why? Yes. There aren't 2 more letters stated. Not so much that you're on the right track. It's that if I'm at a C and I'm checking 2 ahead, there isn't a 2 ahead. Right? Taco, T-A-C-O, it has 1 letter ahead, but it doesn't have 2 letters after it. There is no taco doesn't have a character to go right here unless I actually put one there, right? So that's what happens there. Whenever you're looking ahead, you got to be careful about the range, okay? To solve this, what we would do is that we would say length of word to be -2. In other words, let's see. Oops. In other words, since I'm looking ahead to, I should stop 2 before the end. Why? Because if I'm looking ahead to, then, if there's no point at looking at those last 2 characters because they can't possibly contain the right answer. And beyond that, it's so easy to go out of bounds. Okay, keep going. Right, string some digit. Okay, 15. So given a string of numbers, return 0 if there are no digits in the string, but otherwise return the sum of all the numbers in there. So, for example, AA1, BC, 2D, 3 is equal to 1 plus 2 plus 3, because that will give us 6. AA11B33 will give us 1 plus 1 plus 3 plus 3, which is 8. And chocolate will give us 0 because there's no numbers in there. This is actually a bit more straightforward than the previous one we had. It said even note s.isDigit, test if the string is one of the characters 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, which is super useful. It allows us to do shortcut rather than having to write it ourselves, essentially. So for here we can use this specifically for letter in word and total. Here we're doing a running sum, so at the end of the day, once all is said and done, we want to return that total. And now we just iterate. For letter in the word, what do? We will say we will ask if letter is digit. You can leave out the is true because, again, it's going to return true or false. If it is a digit, that means that there's a number that this can be converted to. Num is equal to int letter. You can change that letter into a number if it's a digit, right? And then do total plus equals that number. And there we go. Again, remove those. Print. Yeah, I just plan on moving through this as quickly as possible. Letter is digit. Oh, yeah, is digit, lowercase. And there we go, 6. Very straightforward kind of question there. Given an integer, return the sum of the digits 0 through 9 in that integer. So very similar, but different. So there's actually a few ways to do this. There's one-liner we can do this with, which is, two-liner. No, one-liner, we can do it in one line. So def sum digits. But basically here what we're trying to do is we're trying to add up all the digits. Now we've shown you how to do this one in a few different ways over the semester, believe it or not. We've got right here we're doing 1 plus 2, 1234 is equal to 10 because 1 plus 2 plus 3 plus 4. 1000 is equal to 1. And then this number is equal to, negative 581 is equal to 14 because 5 plus 8 plus 1. Now, most of you solve this by just simply converting it into a string, right? It's very straightforward to just convert it into a string, and then you can iterate over it, because that's been the main problem. You can't really iterate over this number, right? Now, turns out we already wrote a function that iterates over a string and adds up the digits in it, so might as well use that. And yes, there's no reason why you can't do that on the exam, which is to call previous stuff. So return some string digits. Now, this is not a string unless I turn it into a string by using the str function, and now it is a string. So turn that number into a string, and now suddenly I have the answer I was looking for. Okay, which is this, which is 10. So we should see a 10 now print out in there. So there, I've used, and that's the wonderful thing about functions. You're like, aha, I can use this function to solve a problem that I've already solved just by making a minor adjustment. Right? Everybody followed that? Because honestly, if I was going to solve it using just by turning it into a string, it literally would look the same as this. The only difference would be I would just simply have this, and I would just simply say, instead of num over here, I would go with different values. I would say for num, for a letter in num str num, and then I would just change this over to like n or something like that. Okay, so it's exactly the same. There was really no point in rewriting it. Now, the real way to do this, the way to really correctly do this is to use a while loop, right? First off, if our number is less than 0, then we will just simply say number is equal to num times -1. So we'll just convert our number into a positive number if it's less than 0, so we don't have to worry about negative numbers that way. Okay. Next is while we do our same thing. Total is equal to 0. Return total, and then we'll go back to what I just interrupted, which is while num is greater than 0. What do? we get the last digit of this number. Last digit of this number is equal to the num mod 10. So again, use modulo 10 to get the last digit of a number. Say total plus equals the last digit. And then this should look familiar, this format. Then throw out the last digit by saying total total is equal to, not total, but num is equal to num divide 10. So here, what we did is that we got the last digit. Here we throw out the last digit, and we add the last digit in here. And that is going to be more efficient. But again, for this kind of operation, efficiency is not really what we're looking for, and I'm looking more for your problem-solving abilities at the moment. We get into efficiency, and we care about efficiency in later classes. Okay. So here we go, Monte Carlo. So this one was the primary one I got to, and then whatever time I have left, I'll work on the other problems. Okay. In the board game Monopoly, if you haven't played it, first off, my advice, if you ever actually play it, read the darn rules and don't go with what the rules you think are, because the rules you think that are the rules are wrong because you just added in random rules yourself. It's what everybody does. There should be a runaway winner very quickly in Monopoly. The game doesn't really last that long because one person will crush everybody else into the dirt. It's just the way it works. So in the board game Monopoly, players move around by rolling a pair of 6-sided dice. Rolling doubles, such as threes, 2 3s or 2 5s, so getting a 6 with 2 3s or getting a 10 with 2 5s, that's awesome because you essentially get a second turn. You get a second turn and you get to roll again. You do it again, and you can, if you do a second pair of doubles, congratulations, you get a third extra turn. And then finally, if you roll a fourth, that third set of doubles, you don't get a fourth extra turn. You go directly to jail for speeding. That's the way the game works. So, it doesn't happen that often, but it does happen. It's not, But the question for this one is, how often do these extra turns actually happen? So what we're going to do is that we are going to write a Monopoly program that will simulate 100,000 Monopoly turns. Extra rolls due to doubles count as a turn. Where a turn is a single roll of the dice or more of the... so they count as part of the same turn is the thing. So where a turn is a single roll of the dice or more if the user rolls double. Your program should print out the number of turns we have with a single double, with 1, with 2, and then the one where we go directly to jail. Honestly, I would weight this a bit differently if I was rewriting this, which was simulating 10,000 dice rolls, handling doubles, handling 2 and 3 digits doubles in a row, and then presenting the data in percentages. Here, I would so first off, let's go ahead. If I were rewriting this today, I'd say our first thing in the rubric would be basically simulating rolling a pair of dice. So let's do that. But instead of rolling a pair of dice, I need to generate 2 dice. I need to just figure out how to roll with single die first. Roll, and then return random. And again, what it is that we can use rand range here. Rand range gives us is unique. It gives us, it is from start to stop inclusive. Oh, sorry, rand int gives us the endpoint. My bad. If you always forget that, though, by the way, there's nothing stopping you from doing rand.choice, right? Rand int returns A and B inclusive. There we go. 1 to 6. We want to include the endpoint here. So that gives us a 6-sided die. And again, if you're super worried or paranoid about how that's going to work, just do this. dice, die is equal, or we can do die or faces is equal to 1, 2, 3, 4, 5, 6, and just simply do random dot choice from that dice, from those faces. Super easy way. Don't panic about it, in other words. Just get your code on the board. So here we go. So we need to write a function that basically simulates a turn, def monoturn. I'll just call it monoturn for monopoly turn. And what it should return is, well, what we care about are, this isn't a win or lose. This is caring about how many doubles there are, right? So let's go ahead and figure out what that data is, right? So we want to return the number of turns without a double, 1, 2, or 3. So that means I want to return an integer. So I'll return 0, 1, 2, or 3, depending on things. By default, I'll return 0, because that's going to be kind of the idea. If I don't roll a double, that's the most likely outcome. So let's see. Die 1 is equal to, so here's how a monopoly turn will run. We'll roll the dice. Roll, die 2 is equal to roll. So this is probably the most common mistake the most common mistake I see with like two-sided dice rolls is like rolling a die 1 and multiplying it. It's not really what you want to do. The other one I often see is well, we'll see as I write it, but it's essentially re-rolling the die too soon, or comparing something to a value we don't have. So die 1, die 2. If die 1 equals die 2, if they get the same result, so a common mistake here might be if die 1 is equal to roll, where they reuse roll over here, and that generates a new random number. So if die 1 is equal to die 2, guess what? We've got a double. If they're not equal to each other, great, return 0. So if die 1 is equal to die 2, we'll most likely want to return 1. But we're going to need to re-roll. What I'll do to re-roll is I'll copy this same code that I have. Right? I'll copy, to re-roll the dice, I'll roll die 1 and die 2 again. And then I'll ask if, and you know what? Yeah, if die 1 is equal to die 2 again, if they are again equal to each other, then I'll need to handle that. But otherwise, return 1. And I can do that as an else, or I can leave out the else. It doesn't matter. I'm just going to leave out the else. It's going to look very kind of weirdly symmetrical if I do that. So now, we've rolled 2 dice in a row, which is great. That's most likely going to mean, great, return 2 instead of returning 1 and returning 0. And then finally, though, we need to roll one more time. So we roll the dice once. If they're equal, that means we got an extra turn, so we roll them again. If we roll them again and they're equal, great, we got yet another extra turn. So we got to roll them again a third time. So in this case, if die 1 equals die 2 again, then that's the last time we go to jail for speeding, so we return 3. We don't go any deeper. It's a weird way to do it, but it works. But this is the way it would work out in terms of Monte Carlo simulation. Yes, technically, when you're looking at statistical evaluations, you're supposed to kind of look at all the stuff that you don't roll. In other words, keep rolling beyond this, but that wouldn't get us what we wanted, because it would need to be because what we care about is in a row over here. So monoturn. So here we could run monoturn and make sure that it will do just fine. It's not going to crash. Print 6, 0. We're going to need a 0. That makes sense that we would get zeros. And we could go for a while without getting zeros because, 1. That makes sense, right? You have a 1 in, and if you think about it for just very briefly, you have a 1 in 6 chance of rolling doubles, right? There's 36 possible combinations. Only 6 of the, because you've got 6 sides on one, 6 sides on the other. So the only way you can get a pair of 1s is by rolling 1 and 1. Only way to get a pair of 2s is rolling a 2 and a 2. Only way to get a pair of 3s is 3 and 3. Same all the way up to 6, so there's 6 out of 36 that are doubles. So we'd expect 1/6 of those to be the case. So now we would do now what we want to do is do 10,000, what I said. I think it said 100,000. Trials is equal to 100,000. For in range trials, so we want to do this trials number of times. And what we're looking for is the, let's see, and then we want our result to be equal to monoturn. Now this, in the original rubric, is most of the points. Basically, doing 100,000 of these trials, and then, and just doing 100,000 of these trials and not collecting results. Which, again, I've reworded the ones I've done on the exam a bit differently. So here you go. For blank in trials, result is equal to monoturn. And it can even detect whether or not it's going to be a 3, 2, 0, or 1. That's pretty cool. Okay, so we get the result, but now we got to keep track of our results. So results is equal to a dictionary, and this is easy. And again, this is easy enough where I can just simply list them out. There's going 0 is a possible result, 1's a possible result, 2's a possible result, and 3 is a possible result. And we've seen them all exactly 0 times. If this format makes you uncomfortable doing it like this, right, then you can just simply create an empty dictionary, and you can just simply say results for 0. How many times have I seen 0? I've seen it 0 times. And then you could do that, and then you can just simply copy paste that as need be to change it to 1, 2, 3, and that ends up being the same thing, right? Either of those work. If this notation freaks you out, then just do it the way that's going to be easy for you to write it. For blank in trials. Result, monoturn. Okay, so we got a result here, and then we simply say results, and I have this bad habit where I do plural and singular. Results of result. So let's go ahead and change this variable name to our num doubles. Make it descriptive. So that's how many doubles we got, and we'll simply say results of that number of doubles gets incremented by 1. And then we just need to print out what our values are. For num doubles in results, print that value. So for the key in the dictionary, print out the key and results of the num doubles. I'm using large things because I've got an autocompleter going on here, and that's useful. Okay, now this would be a 1-point mistake if you turned it in, but again, that's why we test our code. And the reason it's a 1-point mistake is because I'm asking for percentages, and here I'm getting total number of outcomes. So again, to turn it into percentages, we just simply take the number of results we had and divide by the number of trials, total number of trials. Oh, divide won't work. Number of trials. And there we see that we get About 83% of the time, we're not getting doubles, right? That makes sense. Most of the turns, you're not going to get double. 13.7% of the time, you're going to get one double, but 2% of the time, you get to roll. You get that second juicy extra turn, and then 0.5% of a time. So a 1 in 200 shot of just simply of your turn being all messed up and getting thrown into jail. So overall, exciting but an unlikely event. Okay, let's see. We've went over this one. So let's go ahead and scroll back up to some other ones, right? Back to the file reading one. Okay? So suppose we have a question named numbers.csv, which contains a bunch of integers, 5 per line of text separated by commas. Write code below that will open the file, read the numbers from it, and print out the sum of all the even numbers in the file. For example, the file might look like this, right? And notice that there's 5 numbers per line. It will most likely be something else, but the reason I give you an example is so that you can use that example. And then here, it gives me, and then I just simply quantify it by saying all the even numbers here. Now, again, what I don't want you to do is simply copy paste this into a list and hard code that in. That's defeating the point of the problem, which is, do you know how to read files? So let's go ahead and go back up here or into organized. So def sum even nums. What did I say was? Yeah. So here we go. Write code. So when I say write code, by the way, you can write a function or you can decide not to write a function. I like doing functions for everything, though. Makes everything a lot easier to test. Sum even nums. Okay. From file. Yeah, only one. Okay. Files. Or file. It's not files. File name. Okay. Here, what we'll do is that we will. I'll go ahead and read the other way, even though it's completely unnecessary. Data is equal to open file name in read format. Then what we'll do is I'll say lines is equal to data.read lines, and that will dump all the lines into this. Okay. For line in lines, and that's why I say you can just easily do it the same way with a regular for loop, just iterating over the file, but we can do it this way too. But long story short, this line still needs to be split up into multiple parts. So I'll do that, parts, or rather multiple numbers, which we'll do. The number, so this line is made up of multiple numbers. For me, it makes sense for me to use plurals and singulars judiciously. That just makes sense to my brain. If it doesn't, if using for line in lines, if that single S makes it too hard for you to read, then don't use it. Use something else. Okay? For line in lines. For number, line dot split. So, and again, we're going to be splitting by that string. It's a string now, so we split by commas. Okay. And then here we kind of need to do a nested for loop, right? Because we have so for everything in the line, everything over here. Sorry, we have this all over here for line in the lines. We split up the line into numbers. Now we have to go through each, and we can't just simply say ask with an if statement. We have to go through each of those individual numbers. For num in numbers, okay. Oh, and don't let numbers confuse you, because that's actually a poor naming on my part, because again, what we'd have to do is we'd have to say num is equal to int num, convert it to an integer, so we can ask the all-important question, are you even or odd? And we're checking for even numbers. So if num mod 2 equals 0, so if I divide by 2 and I get no remainder, it's an even number. Make sense? So now, if that's the case, then I want the sum of all the even numbers. In that case, I'll need to do a running tally. So over here, we will do total is equal to 0. If the number is even, num plus equals, sorry, not num, but total plus equals num. And then what do? We will, well, that's it actually. Return total. Okay, there we go. And that will be that one. It is mildly complicated by the fact that we have a for loop in there, but basically, again, it makes sense when you think about it. We're iterating through each of the lines, and then for each line, we have to iterate through each of those individual parts. Don't let the fact that there's a nested for loop throw you off. It makes sense when you're writing it. Okay. Let's see. Swap ends is super easy to do. Here, where basically what we're doing is that we're changing the numbers. Right? Swap ends is not that hard. Here, 1, 2, 3, 4, 5 becomes 5, 2, 3, 4, 1, 15, 31, 21, 17, 28. The 15 and the 28 swap places. And here, -1, 100, 100, -1. Now the main thing over here is that to swap numbers, you need three variables, or you need a temporary variable, okay, to swap two numbers. Because if you think about it for a second, okay, so we've got the first, so let's go ahead and we've got the numbers. We want to take what's at the end and move it to the beginning. So numbers -1, and we've moved it over here, okay? And then you go to do the same, where we take the last number, numbers, okay, the last digit, and we want to move something into that. But as we're writing this, we're realizing, wait a second. If you're being observant, you're thinking, wait a second. I've just taken the last number and I moved it and copied it into the first position. I overwrote the first position. So if I'm doing this one, 5 to 1, then right now, this is what I have, 5 and 5. And there's just no way to get around by that. So what you have to do is add a temporary variable. Store what you're overwriting. Numbers is equal to 0. Now it's safe to overwrite because we've saved that number. And then take the number you've saved and write over that value. No need to return here because what we're asking you to do is just modify the list, and it's modified. Okay. Okay. Oh, this one's annoying. Everywhere. Do we have time for that? What else do we have? Okay, everywhere. All right, yeah, those are good problems for you to leave on your own for the most part. Given the string. Oh, yeah, totally forgot about that problem right over there. 19 just hanging out there because that's definitely going to also be on the exam. Right? Glad I didn't miss that one. Given a string, write a function that returns the most common letter in the string. Use a dictionary to do this because technically with letters you could return, and if we're just dealing with ASCII values, in other words, English letters, then that you can technically just do that with just letters. Sorry, with a list. But here we need to do this with the dictionary. Returns the most common letter in the string. Use a dictionary to do this. So I'm going to be basically as unsubtle as I can to do this one because, for a lot of you it's going to be definitely easier to do this one. Just without having to remember, how do I sort this thing? And instead just go straight for the answer. So def most, I didn't give a function header over here. Most common letter in this text. It's a string. It's not necessarily a word, so I'm not going to call it a word. I'm not going to call it a string because the string's the type. So I'm going to just call it text because that generally works there. So most common letter in some text. We need a dictionary. I'll just call it D for a dictionary. 4-letter in text. And this is how we populate the dictionary, by doing how we count. What we need to do here to find the most common letter is that we need to count how many times each letter occurs. And you can't just iterate through and say, okay, I've seen this letter is now the most common, and then update as necessary. That's not going to give you the right answer. There's going to be plenty of situations where that will give you the wrong answer. Instead, what you have to do is you have to count all the letters and then make a determination. So you have to keep a running tally of all the letters, and the only way to do that is a dictionary. You can't have a single variable to do this. So the dictionary is great when you don't know how many of those variables you need. So 4-letter in text, basically saying what we're going to ask, am I counting this letter yet? If letter not in D. If it's not in my count of letters, this is the first time I've seen the letter. So D of letter is equal to 1. I've seen it once now. Otherwise, I've seen it before. So what I should do is I should say the count of how many times I've seen this letter should go up by 1. Make sense? Or, again, that's a shortcut for D of letter is equal to the count of that letter is equal to the count of that letter plus 1. Okay, counts is probably a better variable name for this. Now, doing this would be most of the points right there because congratulations, you've shown that you have learned and how to apply going through a dictionary or a list to find the most, to do a count of this. So how do we end this? We have to find the most common. Now we could sort this, but honestly, let's go. Now is the time when we can make use of the tools that we've already learned for biggest and smallest, finding this biggest date, the date with the highest number. So we're going to say most common, most letter, actually I'll just call it the answer is equal to an empty string right now, and then the highest count is equal to 0. For each letter in our dictionary, if the count of that letter, what we've stored in the dictionary for that letter, is bigger than what the largest number we've seen so far, and by definition it will be, even at 0, because guess what? It's always going to start, the values are always going to be at least 1. If that's the most common letter we've seen, then we set that value to be the highest count. And then we say answer is equal to that letter. And at that point, that's their answer. Return the answer. All right. So what I'm going to do is I'm going to stop recording and save this and immediately upload this so I don't forget. So let's go ahead and do that. Stop recording.